Okay, let's just dive right into this explainer. Today, we're exploring a technological leap that is, quite literally, about to rewire our world. I mean, we're talking about a shift so profound, it's going to completely change how we tackle the world's absolute most impossible problems. You know, those tangled, infinitely complex mysteries that would make our current, most advanced supercomputers just completely choke. Things like modeling climate systems down to the exact molecule, or curing diseases right at the cellular level. We are looking directly at the dawn of quantum supremacy. Now, I know it sounds like pure science fiction, but trust me, it is rapidly becoming our concrete reality. To really wrap your head around the sheer magnitude of this shift, I want you to imagine something. Picture yourself standing at the entrance of a colossal pitch black maze, right? And it's filled with millions of twisting, turning paths. Traditional computing essentially forces you to walk every single one of those paths one by one. You walked on a corridor, hit a dead end, backtrack all the way to the beginning and try the next one. It is mind-numbingly tedious. But what if you could suddenly split into a million versions of yourself? Imagine just exploring every single path of that maze at the exact same time. And that massive shortcut, that's the core of what we're talking about today. By completely throwing out the old rulebook and rewriting the physical rules of how a machine processes data, we are trading a painstaking linear trial and error process, one that could literally take millennia, for a simultaneous flood of processing that finds the exit in a matter of seconds. We aren't just putting a faster engine in the car, we're fundamentally changing how the problem is approached in the first place. All right, so let's kick things off with Section 1, entering the quantum maze, and looking at the limits of traditional bits. To really appreciate this quantum leap, we first need a quick refresher on the invisible mathematical wall our current tech is slamming into. For decades, our entire digital universe, from the smartphone sitting in your pocket right now to the highly complex fly-by-wire systems actively keeping fifth-generation fighter jets in the sky, has relied entirely on zeros and ones. We all know the classic bit, right? It's a tiny microscopic switch that is definitively firmly on or firmly off. It's a strictly binary system. Now here's the thing. Those binary bits work flawlessly for everyday linear tasks. Sending an email, streaming a video, doing basic math. Bits handle all of that beautifully. But the physical universe? It isn't linear. It is deeply chaotic and exponential. And that is exactly where traditional computing hits this massive, impenetrable wall. When we try to calculate things that grow exponentially, the raw computing power needed to keep up with the physical world it just can't scale fast enough. And honestly, our human brains kind of struggle to even comprehend true exponential growth. Just think of that ancient legend about placing rice grains on a chessboard, where you put 1 grain on the first square, 2 on the second, 4, 8, 16, and so on. It seems totally manageable at first, but before you even reach the end of the board, you've got a pile of rice larger than Mount Everest. So when we try to simulate complex systems with traditional bits, like designing life-saving drugs by predicting how millions of proteins will fold, or cracking modern cryptographic keys, those billions of interacting variables create a data labyrinth so massive, traditional bits simply run out of time and space. They just choke on the sheer volume. Which brings us to Section 2, Qubits and the spinning coin. We're changing the rules. Listen, to solve these massive exponential problems, we don't just need a faster traditional computer with, a few more microchips strapped to it. We need an entirely new set of physical rules. Think of a normal bit like a coin lying flat on a table. It is definitively heads or tails, but a quantum qubit operates totally differently. It's like that exact same coin, but spinning rapidly on the table. While it's a blur of motion before it finally lands, it essentially exists as both heads and tails simultaneously. And here is a totally mind-boggling fact about making this actually work. To get a machine to behave this way without the outside environment interfering, you have to cool the quantum processor down to a fraction of a degree above absolute zero. That is physically colder than the vacuum of deep space. Crazy, right? So this brings us to a foundational and honestly brain-bending concept of physics known as superposition. This is the quantum state where a qubit exists in multiple states at the exact same time. It heavily defies our everyday common-sense logic, but what it actually means in practice is that a quantum computer doesn't have to test those dark maze paths one by one. It processes all the possibilities simultaneously. It is quite literally living in every timeline of the maze all at once. And when you build this into a real-world application, the results are just staggering. Imagine an incredibly advanced air defense system. Instead of calculating one specific trajectory at a time to track an incoming threat, it looks at all possible future positions simultaneously to mathematically intercept a supersonic missile.
Quantum computers use the deep underlying logic of probability to instantly map out the entire board, and then basically collapse the probabilities onto the exact right answer. Moving on to Section 3, a system of systems shift. We are entering a new era of technology.
I really cannot overstate this point enough. We aren't just talking about upgrading to a faster hard drive here. We are talking about a true system of systems shift. To put the sheer scale of this technological leap into perspective, it would be like upgrading directly from a basic, wooden canvas propeller plane straight into the cockpit of a sixth-generation fighter jet that's seamlessly managing an entire swarm of AI-driven drones. It entirely redefines the outer boundary of what is physically possible for us to build. Let's actually look at a concrete example so we can really grasp the true scale of this disruption. Take the number 128. Specifically 128-bit encryption. Right now, today, this is the gold standard algorithm securing almost our entire global digital infrastructure. It protects everything from your personal banking passwords and private hospital records, all the way up to highly classified national security communications and global power grids. Now, if you used the absolute most powerful traditional supercomputer on Earth today, just guessing one combination at a time, it could take the entire age of the universe to crack a 128-bit code. But a quantum computer, running specific algorithms, it could potentially shatter that exact same code in minutes. Seriously, just sit with that for a second. Minutes versus the entire age of the universe. It can pull this off because it doesn't have to guess. It literally sees the entire maze of mathematical combinations at once and instantly isolates the key. Okay, let's jump to Section 4, the global quantum race, and the keys to the next century. Because the geopolitical and economic implications of this kind of power are so incredibly staggering, we are currently witnessing a massive, high-stakes global race to achieve true quantum supremacy. I mean, whoever masters this technology first essentially holds the keys to the next century. We are talking about unlocking the ability to map complex molecules to achieve limitless clean fusion energy. We're looking at perfecting genetic editing to literally cure diseases at their biological source without any of the trial and error. And, like we just talked about, the absolute power to crack pretty much any modern encryption on the planet. Nations all around the world are quickly waking up to a pretty harsh reality. Being second in this race is simply not an option. Being second means your infrastructure is vulnerable and your scientific progress is decades behind. This intense urgency is triggering massive, sweeping national strategies aimed at dominating the quantum landscape. We are seeing multi-billion-dollar state-backed initiatives being spun up almost overnight, like India's highly ambitious national quantum mission, strictly to ensure they are at the absolute forefront of this technological revolution. And while all of this sounds entirely like it belongs in a sci-fi novel, it is so important to remember that it's grounded in absolute reality. This tech relies on the exact same scientific realism that allows us to look up at the night sky and understand how heavy elements are forged in the extreme pressures of distant stars. It's the exact same science that explains how microscopic DNA physically carries the vast, complex history of human evolution. It is simply us finally learning to speak the universe's native language. Just as the invention of the first jet engines completely redefined global travel and the very nature of warfare back in 1944, leaving old mechanical technology utterly obsolete overnight, quantum computing represents the next great frontier of human capability. It's a hard, dividing line in history. There is going to be the world before quantum and the world after. So, as we wrap up this explainer and stand together at the very edge of this vast new quantum maze, I want to leave you with one final thought. In a world that is increasingly dominated by unbelievably complex data, simply staying curious is your greatest tool. Are you ready to embrace that complexity and step into the future of computing? Because, ready or not, the quantum era is already arriving. Keep questioning, keep learning, and I'll catch you in the next explainer.